So it is my great pleasure to introduce our next speaker, Harald Wiltsche. You all know Harald as the co-editor of the volume Phenomenological Approaches to Physics. You will soon also know him as the co-editor of Phenomenology and Cubism, which is forthcoming in December. And most importantly, Harald is my boss. So Harald, the floor is yours.
Yeah, thank you so much, Philipp. Yeah, this is not exactly how I expected this to go. So I woke up in the morning, had a bit of a sour throat, and then I thought I should try to be a responsible grown-up for once and got myself a test kit, and there you go. So yeah, sorry that I have to do this in this way. Thanks so much, nevertheless, to all of you for being here. And thanks, of course, to the organizers for giving me the great opportunity to give this talk today. I mean, originally, I was even more excited to be part of this conference. For one thing, it is the first talk I'm giving at my former home institution in my hometown, so that's pretty exciting. And the second reason for excitement was when Philipp Berghofer reached out to me and told me that he wanted to organize this conference together with Philipp Goyal. That in itself, of course, was great news. Both Philipps are co-authors of mine. We are, connected through different kind of projects, and reconstruction is a topic that's dear to my heart. So all of this, of course, is a reason for excitement. But then Philipp Berghofer even managed to sweeten the deal by asking me if I were interested in giving a commentary on Michel Bitbol's talk. And that, of course, was even more interesting. In general, I feel deeply indebted to Michel's work. I remember when I got interested in this connection between phenomenology and physics. I mean, it was a little bit like looking at a desert landscape. There wasn't a lot of work, with very few exceptions. But Michel, of course, was one of these exceptions, and I learned a tremendous a lot from his writings, and for that reason, I'm really honored, and I appreciate the opportunity to engage with his work in the context of this conference. One caveat, though. We had originally planned to do a, classical, traditional commentary where I would get the talk from Michel well in advance and then could think about what to say about it. But, I mean, the medium of my talk today is a perfect example for that. Life happens, and sometimes life world contingencies have different plans for you. So for different reasons, this traditional classical commentary didn't work out. So I heard Michel's talk for the first time as well. So the challenge I had in preparing this talk was, to almost engage in a bit of counterfactual reasoning and thinking about what Michel probably would say and how I would react then to what I thought his talk would be. I do hope that I did a reasonably good job. I think, of course, we exchanged a couple of emails, so it was not completely shooting in the dark. But the aspect I want to focus today is a recurring theme in a lot of Michel's writings, namely various attempts to try to make sense of science, to try to make sense of physics and quantum mechanics in particular from a genuinely transcendental perspective. And in order to deal with this topic in Michel's work, I will follow the following structure. I will, in the first part of my talk, raise the obvious question: what is it actually we're meaning when we say transcendental? What is a transcendental approach to physics? What is a transcendental approach to quantum mechanics? And I want then, in the second part of my talk, to take a look at one specific way in which you can be a transcendentalist about quantum mechanics. And this specific way is closely connected to Michel's reading of Niels Bohr, because, spoiler alert, Michel is one of those who think that the only way to really make sense of what Niels Bohr's philosophy of quantum mechanics amounts to is to look at it from a transcendental perspective, or see Bohr actually as thinking from a transcendental viewpoint about quantum mechanics. I will lay out what this means in the second part of my talk, in order to then talk about a few problems that I think are connected to this transcendental reading of Bohr. And I want then in the final and fourth part to wrap things up by, first of all, of course, offer a conclusion, and then take the bits and pieces and see how they are connected to the reconstruction program. All right, so this is the general plan. I hope my voice is going to work for the whole talk. I'll give my best. So what do we mean with transcendental? I will not engage in any serious Kant scholarship here, but still it would be weird to talk about the word transcendental without starting with the man, the myth, the legend, Immanuel Kant. So in order to get the ball rolling, I have 3 quotes for you, 2 from Kant himself and 1 from a quasi-neo-Kantian early 20th century, Nicolas Hartmann. So here goes the first quote. I call transcendental all knowledge which is occupied not so much with objects as with the mode of our knowledge of objects, insofar as this mode is to be possible a priori. Second quote, the word transcendental does not signify something passing beyond all experience, but something that indeed precedes it a priori, but that is intended simply to make knowledge of experience possible. And then finally, Nikolai Hartmann, the transcendental method is the procedure according to which, beginning from the reality of an object, one can infer the conditions of the possibility. So what does this all mean? Well, we start from de facto experience, from a de facto given body of knowledge, and then the transcendental analysis kind of works itself backwards regressively to in order to do what? Well, to identify the necessary conditions of the possibility of this experience or body of knowledge. Just to give you a very simple toy example to get the intuitions going. I mean, for all intents and purposes, in everyday situations, we usually like to think of ourselves as, competent observers, in the sense that we typically are quite good in distinguishing between objectively existing physical things, I don't know, the chair over there, from, say, the figments of our mind, the pink elephant that is currently standing in my hotel room over there. But doing so, of course, requires a concept of objectivity, and transcendental analysis would then be in the business to actually unveil, to unearth, to spell out this very concept. But of course, such a project is by no means limited to the manifest image, so to the sphere of, life world objects, elephants, cars, chairs, trains, and stuff like that. We can apply this to science. And here is the first quote by Michel and others. Elaborating a transcendental epistemology of physics means to undertake a reflective research about the indispensable preconditions of our knowledge and their relevance to the structure of physical theories. So basically the same idea from before. It is about unearthing the necessary conditions of the possibility of experience and knowledge, but just now with a focus on a very special realm, the realm of physical theories and the knowledge that's embodied in them. Or to just give you one other example, Sunny or Yang, in a quite similar vein. Until now, almost all philosophical investigations of quantum theories have either taken the concept of objectivity for granted or prescribed it as some external criterion, according to which the theories are judged. I adopt the opposite approach. I start with the premise that quantum theory conveys knowledge of the microscopic world. and regard the general meaning of objects as the question whose answer lies within the field. This work asks quantum theory to demonstrate its own objectivity by extracting and articulating the general concept of objects it embodies. What general conditions hold for us in the world we are in, so that objects, classical and quantum, which are knowable through observations and experiments, constitute reality? How is knowledge of the quantum world possible? These are part of what Kant asked. How is empirical knowledge in general possible? So, to summarize, transcendental analysis is, first of all, a regressive, backwards working undertaking in which we start from a given experience or body of knowledge in order to then unearth the necessary conditions of the possibility of this kind of experience or body of knowledge. This is basically, even though this is still quite general, this is the understanding of transcendental with which I will work in the following. However, I want to add 3 qualifications, even though I have to say some of the things I might say now might sound a little bit abstract. I'm just flagging these issues, and we'll come back to them when I talk about Niels Bohr, but it makes sense to put this out already here. First, and not everyone agrees with this, but many transcendentalists, and Michel included, would claim that the difference between so to speak, transcendental meter level and the empirical object level also comes with quite important logical consequences. This is sometimes discussed under the label of naturalized epistemology versus transcendental epistemology. And the nutshell version of the story is, if X is a necessary condition of the possibility and thus constitutive for the body of knowledge Y, then X cannot itself be part or be accounted for in terms of Y. I know this sounds pretty abstract, but this will be discussed in much more detail when I come back or when I talk about Bohr. The second aspect, what I said so far, of course, comes with quite far-ranging epistemological implications. At the very least, what one can say on the basis of what I said so far is that experience is definitely not just the passive registering of data from the outside, so to speak. Because in order for experience to happen at all on this image, transcendental structures, whatever they are in the end, must already be in place, must already be implemented. And again, I will come back to this too. And the third point, and I mean, it would be interesting to tell the full historical story here that really goes from Kant's interpretation of classical Newtonian physics up to neo-Kantianism in the 19th century and the relativistic revolution by Einstein, and how Vienna Circle philosophers and Moritz Schlick in particular tried to make sense of this relativistic revolution and answered back to Kant and neo-Kantianism, but I don't have time to go into this. So the only thing that's important for my purpose here on a more systematic level is we must be cautious with the notion of necessity in this expression, necessary conditions of the possibility. Contemporary transcendentalists, and Michel included, typically work with a notion of conditional necessity. And this is how Michel defines this notion. Certain constitutive principles are necessary under the condition that a certain practice of research is implemented. And when practices of research change, and looking into science history, we know that they do change, then of course the constitutive principles may change too. So this is what I want to say about the word transcendental. This concludes the first part of the talk. I now want to give you a rough overview of what in the context of this talk is important about Bohr. And let me start with a couple of very, very general remarks about classical physics. So a crucial idealization in classical physics concerns the possibility of what we could call ideal measurements. So measurements that do not alter, that do not change the state of the measured system. And although actual measurements typically do not live up to this ideal. I mean, think of all the examples, I don't know, measuring the pressure of your car tire, and you put the thingy, where I don't quite know how it's called, on your tire, and it goes, and by measuring, you have changed the system. So although measurements typically are like that, in classical physics, we treat this as a basically just contingent matter of technological realizability. So this is basically how neoliberals think about the challenge of climate change. We can act as we always did. Technology will save the day. But Bohr considered Planck's discovery of the universal quantum of action, H bar, pretty much as the essence of quantum mechanics, because precisely it undermines this very notion of an ideal measurement. Due to the finite size of H bar, measurement interactions can never be neglected in quantum mechanics. And this is because the measurement is at best of the same order of magnitude as the interactions it's meant to measure. And in the eyes of quite a few of the founding figures of quantum mechanics, this has quite far-reaching epistemological consequences, as you all know. Just as one random example, Werner Heisenberg, what we observe is not nature in itself, but nature exposed to our method of questioning. Or in Bohr's own words, and you find similar passages all over Bohr's work, we must accept the fact of a fundamental, quote, inseparability of knowledge and our possibilities of inquiry. And of course, this must be taken very, very seriously. So for instance, Bohr is very explicit about the fact that it simply makes no sense to say that we are disturbing or even creating a phenomenon by observing or by observation in quantum mechanics. And the reason is that words like disturb or create come with ontological judgments, implied ontological judgments about the system pre-observation. There is or isn't something that can then be disturbed or created by an act of observation. But inseparability of knowledge and our possibilities of inquiry means that such pre-observation talk is meaningless. What many interpreters of Bohr found very puzzling, of course, is Bohr's recurring insistence that, and I quote, the description of the experimental arrangement and the recording of observations must be given in plain language. So basically here, what he's saying is no matter how far quantum mechanics departs from classical physics, the description of the experimental setups of the measurement apparatuses must always be given classically. Here is just another quote saying exactly this. The mathematical formalism of quantum mechanics merely offers rules of calculation for the deduction of expectations about observations obtained under well-defined experimental conditions specified by classical physical concepts. And this is true even in the limiting case where we make our experimental setup part of the quantum description, which of course we can, because even then, quote, some ultimate measurement instruments, like the scales and clocks, which determine the frame of space-time coordination, must always be described entirely on classical lines. And I will come back to what's coming now, and consequently kept outside the system subject to quantum mechanical treatment, end of quote. What seems to be a quite sharp rift between quantum and classical, as I said, puzzled many readers of Bohr, because basically it seems to leave us with two main options. And one of these options is to accept or advocate some kind of two-world ontology, being a quantum realist about small stuff and being a macro realist about the big stuff. But there are, of course, and I will not go into detail here, many arguments against such a view. And even if you only look at the coherence of Bohr's own writings, I mean, this does not fit at all with the passages where Bohr is very, very clear that the line between quantum and classical is drawn arbitrarily due to pragmatic considerations. So how could you have this sharp ontological division if then the point where you draw the cut is arbitrary? The other option would be to read Bohr epistemically, classically as an instrumentalist. So that would basically mean to suggest some kind of epistemic agnosticism regarding the quantum realm. But this also doesn't seem to be an option for various reasons. And again, if we just only stick to the coherence of what Bohr himself writes, Bohr is quite clear that for him, quantum mechanics is not just an instrument, but embodies an entire epistemology that concerns, quote, what we can say about quantum nature. So it's exactly at this point that Michel, and he's not the only one, there are a few others, present us with a third option, an option independent from these two, the ontological one and the epistemological one. And this third option is described in this longer passage here. Just as Kant did, Bohr undertook a reflective analysis of the generic structure of our capability to know. However, unlike Kant, Bohr distanced himself from a study of mental faculties, such as sensibility and understanding. He rather focused on the technological counterpart of sensibility, namely the measuring apparatus, and on the intersubjective counterpart of understanding, which is common knowledge. So the basic idea here is, rather unsurprisingly, that Bohr considered the experimental setup, the measurement apparatus, as the necessary condition of the possibility of any kind of quantum experience in the transcendental sense of the term, in the sense in which I have described this previously in the talk. And for interpretation of Bohr, this has really three main consequences. First, if experimental setups, if measurement apparatuses are necessary conditions of the possibilities for quantum experience, then it very naturally follows that there is no meaningful pre-observation discourse. And this also, by the way, fits quite well with how Bohr defines the notion of phenomenon, and I quote Bohr here: "I strongly advocate limitation of the use of the word phenomenon to refer exclusively to observations obtained under specified circumstances, including an account of the whole experiment." The second consequence of such a transcendental reading: if experimental setups, measurement apparatuses are necessary conditions of the possibility, then the fact that they must be described classically, of course, does not have any ontological implications. And here is a longer quote by Michel making that very point. "There is nothing in the physical nature of macroscopic objects that distinguishes them from the microscopic ones, and which rules out the possibility of describing them as quantum systems. Bohr's concern is rather to emphasize the specific function that the measuring apparatuses accomplish in the system of knowledge, that of fulfilling a condition of the possibility of objective experience," end of quote. And again, of course, remember Kant's definition of transcendental as being occupied not so much with objects as with the mode of a knowledge of objects. And this also explains why implementing an experimental setup, implementing a measurement apparatus, is both necessary, while it's also at the same time arbitrary, where exactly one draws the quantum classical line. Although the scope of quantum mechanics is unrestricted, we need to introduce an experimental setup somewhere, because introducing the setup is the necessary condition of the possibility to have quantum experience at all. And this, by the way, is reminiscent of Paris and Zurich's views on the matter. Here's just one quote pointing this out. "Although quantum theory is universal, it is not closed. Anything can be described in it, but something must remain unanalyzed. Although it can describe anything, a quantum description cannot include everything." And thirdly, and closely related to what I just said, remember the part of this longer quote from Bohr, which I read out before. So Bohr's remark that some ultimate measurement instruments must always be described entirely on classical lines. and consequently kept outside the system subject to quantum mechanical treatment. Now, on this view, that the measuring instruments must remain outside the quantum description is a purely logical point. If X is a necessary condition for Y, X cannot be accounted for within Y. And this is really just a version of a quite traditional Kantian argument against naturalized epistemology. And the nutshell version of this argument goes a little bit like this. If epistemology deals with the question, how is empirical knowledge possible, then it is simply self-defeating to rely on empirical knowledge to answer this very question. So what do we think of this interpretation of Bohr? I mean, I will not go into historical considerations. I mean, there are discussions between historians of quantum mechanics whether Bohr knew enough about Kant's philosophy through one of his teacher, Harald, and whether it's plausible that he actually was familiar with transcendental arguments, but I will not go there. What I can say is that there are, I think, quite a few passages in Bohr which have very Kantian ring to them. Bohr, for instance, repeatedly uses a Kantian language when he refers to, and here's one of these quotes, the measuring instruments as the conditions under which the phenomena appear. And there are many, many more passages where he seems to use this rather Kantian language. But more importantly, on a systematic level, one could have the impression that this Bohrian brand of transcendentalism actually might be the best of two worlds. On the one hand, it gives a epistemologically much more nuanced picture of how quantum experience is definitely more than just this passive registering of data. But unlike Kant, there is no reference to mental faculties or subjectivity more generally. And this might be something that looks quite desirable for those who think that a well-behaved theory is one which is purged from all operational, subjective, or experiential notions. But I think there are problems as well, and I will now come to one of these problems in particular. So let me ask again, why is it exactly that the final experimental setup is considered the necessary condition of the possibility for having any experiential contact with the quantum realm? The reason seems to be that the final experimental setup, the final measuring apparatus, enjoys this status because there wouldn't be any quantum experience if this final experimental setup wasn't implemented. And remember, this is also the reason why the final experimental setup, the final measurement apparatus, falls outside the scope of a quantum description. But my worry is, if we follow this criterion, there are many more things that deserve to be called necessary condition of the possibility for quantum experience. And let me give you a concrete example in order to show what I mean. So to repeat, the final experimental setup enjoys the status of a necessary condition of the possibility for quantum experience because there wouldn't be any such experience if the experimental setup hadn't been put in place first. However, if we assume that the outcome of the final measurement apparatus must be registered by a human observer, there also wouldn't be any quantum experience if, say, the lab wasn't filled with the sufficient amount of air. And then the question is, would it make sense to call the air in the lab a necessary condition of the possibility? And going one step further, would it make sense to deny that the oxygen in the lab can be described quantum mechanically? And of course, no, the answers are no. And I take it that Bohr, of course, would agree. But the problem which I want to emphasize is that I simply don't see any room in Bohr's account to distinguish between the experimental setup on the one hand, and let's call them purely contingent, but importantly, epistemically completely irrelevant background conditions like air in the lab on the other hand. And note that this argument doesn't depend on human observers specifically. I mean, just replace air in the lab with being, I don't know, located on a terrestrial planet instead of a gas planet, and I think you get the same outcome. There is, of course, one obvious solution to this problem, and I think it's the solution that Michel advocates. Remember Michel's definition of a conditional necessity as a necessity that depends on the implementation of, and I quote, a certain practice of research. And if you follow this definition, one could argue as follows: whether X is a necessary condition of the possibility in the transcendental sense of the term depends on whether X is part of a distinctive practice that must be carried out in order to achieve a certain epistemic aim or epistemic goal. And arguably, arranging measurement apparatuses in a specific manner is a practice that serves a certain epistemic end, while having air in the lab or being on a terrestrial planet are not connected to epistemic practices in any obvious way. But the problem is, I don't think that Bohr can go down this road. And the reason is this: if you connect the notion of necessary conditions of the possibility with specific research practices, and thus with specific epistemic goals or ends, I think one is practically smuggling an epistemic agent and hence a conscious subject into the account of quantum mechanics one favors. And while I'm not denying, of course, that this might be a perfectly reasonable thing to do, I simply do not think that it's part of Bohr's official agenda. And I think this is one of the points where Michel and I disagree in our reading of Bohr. I agree basically with Fayet and Falls that even when Bohr talks about experience or observers, and I quote them here, his references refer to the observer qua physical system, not qua consciousness. And here are just two more random sources or quotes corroborating this view, namely the view that there simply is no subject in Bohr's account. First one is here. Since in philosophical literature, reference is sometimes made to different levels of objectivity or subjectivity, or even of reality, it may be stressed that the notion of an ultimate subject finds no place in an objective description as we have defined it. And the second quote, the description of atomic phenomena has in these respects a perfectly objective character, in the sense that no explicit reference is made to any individual observer. Hence, my challenge for a transcendental reading of Bohr stands. I think there is no way to distinguish between necessary conditions of the possibility in an epistemically interesting sense and purely contingent background conditions like air in the lab or being located on a terrestrial planet. And that's obviously not a good thing. So I come to my conclusion. One remark right off the bat. What I said so far is not so much meant as a criticism of Michel. It is clearly a criticism of Bohr, if it makes sense to read him in this transcendental way. But more generally, also in the context of this conference, what are the broader lessons we can draw from this? And one conclusion, of course, could be this. If we start from, and again, quote Bohr, inseparability of knowledge and our possibilities of inquiry, then the resulting interpretation of quantum mechanics must also include reference to an observing subject that sets up measuring apparatuses to achieve particular epistemic goals. And other approaches to quantum mechanics can be read to do exactly this. And just without going into any detail, just to give you some examples, especially in the way how Michel reads this position. Consider, for instance, von Neumann's references to an abstract ego that must be presupposed by any quantum description. Or consider London and Bohr's interpretation, on which Stephen French will have a monograph very soon and then spell out many of the details, because this interpretation puts the observer with her, and I quote London and Bohr, characteristic and quite familiar faculty, which we can call the faculty of introspection, pretty much at the heart of quantum mechanics. Or finally, and Michel talked about this in his talk, consider cubism, which on Michel's reading represents a quite radical attempt to interpret quantum mechanics exclusively, and I quote Michel here, from the first person standpoint of knowers or agent. Or consider finally the reconstruction program that I would say, as Michel pointed out in his talk, shows several similarities to a version of transcendentalism, at least. And let me just point out a few of them. First, reconstruction is a regressive undertaking that like transcendental methodology, starts from the given body of knowledge, in this case, the formalism of quantum mechanics, in order to unveil the underlying, and I quote Philipp Goyal here, general principles. And one question which would be interesting to discuss also in connection to Michel's talk would be whether these general principles qualify as necessary conditions of the possibility in the transcendental sense of the term. For Michel, as we heard, they do, but it would be interesting to hear how our physics friends doing reconstruction think about this. Second, like Bohr's transcendental take on quantum mechanics, reconstruction, in many cases at least, favors an operationalist approach, and this is also in particular true for Philipp Goyal. This is a quote from a paper I co-authored with Philipp Goyal and Philipp Berghofer. This amounts to taking as primitive the notion of measurement as well as the notion of an agent or experimenter who's capable of freely choosing which measurement to make and when, if at all, to make it. And third, and this is closely related to the previous point, by favoring operationalism, reconstruction, of course, also takes seriously the role and nature of the agent. Here is a quote from Philipp Goyal. In the operational framework, it's usually left implicit that there exists an entity, an agent, that is capable of observing or registering measurement outcomes, and that the entity possesses the capacity to make changes in device settings without being influenced by the system under study or by past or future measurement outcomes. These notions are usually implicit in experimental science, but the precision required in reconstructive work is such that they sometimes need to be made explicit. As such, the quantum description of physical reality is, from the reconstructive point of view, inextricably context-dependent, and that context is shaped by agential action. This contrasts sharply with the situation in classical physics, wherein one is permitted to speak of the physical state of a system or the universe as a whole without regard to agential action. And finally, and this is my last point, reconstruction agrees with the Bohrian view that the ultimate measurement apparatus must always be described classically. And here is one quote showing this. The classical component of physical reality then effectively acts as a portal for which we probe some other part of physical reality, be it classically describable or not. For example, in an electron diffraction experiment, the experimenter has access to a device that generates the accelerating voltage and to devices that generate deflecting electric and magnetic fields. And can observe flashes on a screen which he interprets as evidence of electronic collisions. But the behavior of the electron, the microphysical object which is commonly supposed to underpin these scintillations, is not classically describable, but it is only through these classically describable bits of equipment that we'll learn about its behavior. And here again, it would be interesting to hear whether Philipp's reason for excluding the final measurement apparatus from a quantum description is a transcendental one. Thanks very much for your attention.
Okay, Harald, thank you so much for your talk. Yeah, questions. So this is from Harald.
Yeah, so Howard Barnum, yeah. Thanks for this really nice talk, and it really helped clarify, I think, a lot about what Bohr had to say, or at least to remind me of things I haven't thought about for a long time. I wanted to address your question about the extent to which postulates used in reconstruction were necessary conditions of the possibility of something, perhaps experience, or perhaps something a little narrower, but like the practice of science. And I think you find people interpreting their postulates, and sometimes even the same postulate, in both ways. I've definitely seen, for instance, I remember a talk by Mauro Dariano where he, like many of us, used, and sometimes we use the principle of so-called local tomography. And he was arguing that this was a possibility for the condition of even doing science. I don't actually view it that way, but I nevertheless am occasionally happy to use it in a reconstruction. So I think, it's very desirable if you can to have a reconstruction that's from postulates that are the necessary condition for some very general aspect of our experience, maybe even of experience itself, or maybe of scientific progress, or maybe of a general research program, but it's not necessary. And that's part of the diversity in this reconstruction program is some people are looking for principles that are more fundamental than others. Other people are in fact really happy with the fact that you can reconstruct quantum mechanics in many different ways and get kind of a cubist with a C view of how to see it from many different perspectives. So yeah, I mean, that's my view, that it is a really great idea to try to look for reconstructions from necessary conditions for the possibility of science, but also it's worthwhile not to insist on it. And I wonder if, do you have any thoughts on that?
Okay, Harald, please remember the weight. Yeah, perfect.
Yeah, thanks so much. I think it's a great question. I mean, to a certain extent, I think what you just expressed was meant to be captured in this bit where I talked about this notion of conditional necessity, where first of all, what is considered to be a necessary condition of the possibility is first of all relative to a certain epistemic practice. And I would say this is what makes this whole transcendental idea in the 20th and 21st century much less lofty than it initially was in Kant. But I also would say that no one says actually that there must be one set of these conditional necessary conditions of the possibility. I mean, there could almost be something like a hierarchy. You could have something, certain necessary conditions of the possibility could really be relevant for the scientific enterprise in general. And then there could be more specific ones with respect to epistemic practices that are part of this more general undertaking, which is considered to be science. And the second thing is also that I think the kind of skepticism people sometimes have with regard to transcendental arguments or transcendental framework is that people sometimes think that probably through this notion of a priori, which you find in Kant, this is some kind of magical surefire way to identify the absolutely certain basic axioms of whatever there is. I mean, I would say this transcendental enterprise is, of course, part of any other scientific discourse, which means that you make a proposal for what you think that these necessary conditions of the possibilities are, and then there will be a discourse about whether your peers agree. So in that respect, I would not think that such a project would be any different from any other area of science.
Okay, Michelle has a question.
Okay, thank you very much, Harald, for your wonderful talk, which is really clarifying on every topic. I just have a question about the introduction of subjectivity in Bohr. You challenged the idea that there was a notion of subjectivity in Bohr, but I think first of all, in the early papers and statements of Bohr, you have many references to the experimental project of ours, about the meaning ascription we do on the measurement results, and all this, and of course, reference to language. Language is difficult to ascribe to anyone else than human beings or similar beings. And at a certain moment, you certainly remember that there was this intervention of Vladimir Fock, the Soviet scientist, who said that he could not accept Bohr's views, especially not import them in the USSR, if there was so much of subjects of it in it, and so Bohr receded, saying, okay, I will remove all this subject stuff from my work and try to focus just on the apparatus. But for instance, when you quote another sentence by Bohr, when Bohr said, the description of atomic phenomena has, in these respects, a perfectly objective character, in the sense that no explicit reference is made to any individual observer. You also see that what Bohr wants to remove is just the individual observer. He didn't say anything about the observer in general, qua giver of meaning and qua provider of projects. So to me, there seems to be an ambiguity here in Bohr's views about the introduction or non-introduction of the subject in physics. So of course, it cannot be an object of the physical theory, as you clearly said, but that it is a presupposition of physical theory cannot be excluded from the bulk of Bohr's work.
Yeah, thank you so much. No, definitely. And I think there are really two levels here. One would be the historical question, whether or not we find enough evidence for the view that either Bohr reserves a certain position for subjectivity consciousness in his overall thinking. Yeah, to be honest, I also wouldn't feel confident enough to really. I don't consider myself a historian of quantum mechanics, and I'm happy to look into this in more detail. But I think what's much more important, I would assume that you completely agree with me on the systematic level. That basically what the argument shows, even if Bohr would have excluded subjectivity and consciousness in the way as I described it, what we could learn from this is that this is a route we should not go down, because basically it would not work for the problems I've pointed out. So basically what I'm saying is, I think the main point I wanted to make was a systematic one, that you need to include the agent, and you need to include a concept of a certain epistemic aim or goal, by which you then distinguish between measurement apparatus and any other contingent background condition. I think that was the systematic point. And yeah, I assume you would agree with that.
Okay, next question is from Mike.
Thanks. I enjoyed that. I find myself agreeing with a lot of what you have to say. Some things I have to think about a bit more, I guess. But I just have a small comment, and it's about similar point to the one that Michelle just made. Is regarding whether Bohr thought about the nature of our cognitive faculties. There was a paper a few years ago by Jan Fay, I think, where I don't remember the details of the argument because it's been a few years since I looked at it, but he argues that Bohr and the people around him were concerned with the way that our tied the notion of classical. So I don't think I agree with Fay's argument, but nevertheless, I think he gets into he presents a bit of textual evidence, if I recall, to the fact that Bohr circle, the people around Bohr and Bohr himself, were concerned with how the structure of cognition is shaped by evolution in a sense of biology. And I don't know if you've seen that, and if you had any comments on it, or if you haven't, I can send you the paper later.
Yes, the letter. I don't know the paper, and I would be very happy if you could send it over, because
we can't hear you. Maybe now. Can we hear you now?
Can you hear me?
Yeah, it works.
Perfect.
Yeah.
I was too quick. I'm speeding
No,
up.
I was too slow.
Okay. No, the letter. I don't know the paper, and I would be more than interested to read it, because I mean it's obviously relevant. And I mean basically this is by the way, this is the first time I'm giving a talk on Bohr, so this is a relatively fresh area for me. So I do not claim to already have complete overview of all the relevant literature, which, as you know, is quite extensive. So I would be very happy if you could send over this piece.
Thanks a lot for this great talk. Your argument about the role of apparatus and its comparison with the role of, for example, the air in the experimental situation was very interesting for me. But I was thinking about the possibility of a more Heisenbergian interpretation of the role of apparatus there, and then perhaps supporting the role of instrument as the condition of possibility of the measurement. In the way that, as you know, Heisenberg understand quantum superposition as potentialities. So it's important to realize that potentiality. And it seems that the apparatus plays the role of the realization. It helps the agent to realize that potentiality. But the error in the experimental situation doesn't play this role. So there seems to be a clear difference between that apparatus and the air. The apparatus realized that potentiality, but the error is just in background in this regard. Thanks.
Yeah, thank you. Thanks a lot. That's quite interesting. But what about my second example? Being on a terrestrial planet or being on a gas planet. Is being on a terrestrial planet having a solid surface in which you can have any kind of experimental situation? Is that something that realizes a potentiality? I mean, I see the direction in which you're going, and that's definitely interesting. Another question, of course, would be, would it help Bohr specifically? But I mean, I agree, it would be one way out, but then nevertheless, I would need to think more about how, for instance, this plays out for the other conditions. And of course, I mean, these epistemically non-relevant background conditions can, of course, be multiplied basically endlessly. I mean, you can come up with all kinds of conditions that are somehow in the background whenever we want to generate a quantum experience. And basically, the argument is then, well, how can you draw the line between what's epistemically relevant and what's epistemically not relevant? And I see the direction in which you're going, but yeah, I think I had to think more about if it's a general solution, but thanks for the suggestion.
I have a brief question or a brief remark. It'd be nice to know what you think about this, so that in experiencing mental phenomenon, we have the experience of noting a certain mental phenomenon and then coming to know it, right? So there's you could say this is the faculty of introspection, but there's this very basic capacity that we have. And it's through that we come to know, right? To know what we're thinking, knowing what we're experiencing, and what we're thinking at a certain moment in time, and so on. I suppose the way I would see it is that the apparatus is that which is carrying out an analogous process in that which we call the physical world. So it seems to me that there is a great and deeper lesson here, that there's sort of a deep analogy, I think, and I think it goes very deep, a deep analogy between this active introspection and that which the apparatus is doing with respect to the quantum realm. So I'd just be curious to know what you think about that.
Yeah, this is very fascinating, and I think I had similar ideas because this recent interest in Bohr also stemmed to a certain extent from a graduate course I was teaching with Tom Reichman at Stanford this spring on Bohr. And at some point we had one session where we were talking about the London and Bower approach and basically how the London and Bower approach would compare to the Bohrian image. And I think we ended up with a very similar discussion, whether in the London and Bower account, you also have this very clear transcendental moment of having a necessary condition of the possibility for, I think in this case, objectivation. But here, of course, it would not be a measurement apparatus. It would be the possibility to direct an act not towards an object, but on a past experience. And this is what phenomenologists call reflection. And yes, I mean, I completely agree. I haven't had enough time to really think enough about where to take this or what one could do with this. But yeah, I completely agree with the basic line of reasoning. So thanks, yeah.
Thanks for your inspiring talk. I must just note some fundamental issues. I feel that you are redefining transcendental. From my view, for Kant, but quantum physics would have been already a transcendental science. So this is something which is beyond the 3D realms of experience. And the other thing is also that for me, Bohr is more the anti-metaphysical guy, which is exemplified in his in this anecdote when he says, looking at the horseshoe on his hut in the mountains, he said he believes it works, even if you don't believe in it. Yeah, and the third point is this distinction about the apparatus and the measurement. There's meanwhile something what we have in contextuality. Maybe you would like to say something, go into this direction later. And also if he says, if Bohr says the experiment doesn't tell us about the preconditions, isn't this something what is against the transcendental view of Bohr?
So thanks. I mean, first of all, and I was hoping that I kind of made that clear in the first part of the talk. I mean, very clearly, the notions of transcendental, we find in contemporary discussions about philosophy of science, philosophy of physics, are of course not the Kantian ones, the original Kantian ones. And I think this is really something that was made pretty clear in the exchange between Schlick and Cassirer, that neo-Kantians realized that, of course, one has to disentangle the methodology one can find in Kant and even change that to a certain extent, but that after Einstein, it was not possible to really stick to the very letter of what Kant wrote in the Critique of Pure Reason or in any of the other places. So I think the historical figure Kant in this discussion really isn't that relevant. The second point, I mean, who Bohr philosophically, metaphilosophically, methodologically was, is of course a topic of huge discussion. I mean, there are, I don't know how many different interpretations of what Bohr actually wanted to say on a philosophical level. And I think this is very often the case when one tries to make sense of physicists also engaging in this kind of more reflective proto-philosophical reflections on what they were actually doing. in their mathematical or physical work, that, I mean, Bohr didn't write philosophical papers per se where it becomes completely clear what he actually wanted to say. So of course you find all kinds of different passages, but then I think it is the very point of the art of interpretation to try to come up with one of these interpretations that probably, I would say, makes a Bohrian position most useful for a general systematic understanding of quantum mechanics. I mean, at least that is how I would think about historical and interpretational work more generally. At the end of the day, we're not just doing this for the sake of figuring out who the real Bohr was, because in many cases, probably this question really is unanswerable. I think where these kind of historical reflections become interesting is if we look at historical figures who had a deep insight in a certain subject matter, but then really ask the question, what can we today systematically profit from what they said about the subject matter? So this is roughly how I, in general, think about not only Bohr, also when I don't know, write about Husserl or Weil or all of these people. I'm not doing it for the sake of figuring out historically who the real Bohr, Husserl, Weil was, but, you know, to make it more useful for the kinds of discussions we're having in right now in systematic regards.
Okay, so let's thank Harald again for his great talk.